Hi, I'm Teddy, and for my senior thesis, I'm doing a custom interpreted language. When I thought of doing an interpreted language, I wanted to take Python, a dynamically typed language, and make it into a statically typed language. Therefore, my new language is named Viper. For the tools, I use C# to build the interpreter, Visual Studio for the IDE, and then Git and GitHub to push the source code remotely. My motivation for building this language is primarily to understand how interpreted languages are built, such as JavaScript, Python, and PHP. I've used these three languages before, and I wanted to give myself a chance to create my own. I also wanted to understand the challenges of building a language, like how parsing complex expressions work. And I also want to address the issue of dynamically typed languages and why statically typed languages are beneficial in the long run. The two statically typed languages I picked as a source of inspiration are TypeScript and Python and Python. TypeScript was created in 2012 by Microsoft to expand on JavaScript and enforce optional typing to make reading code easier. On the other hand, Python is a superset of Python with emphasis on optimizing Python code and allowing the developer to directly call C library functions for better performance. The interpreter, to sum it up, basically just takes one line at a time and interprets it. The difference between the interpreter and a compiler is that the interpreter does not produce machine code. This allows the interpreter to start running the program quickly. But unfortunately, this comes with the cost of less performance compared to a compiled code. So you can see with the interpreter process, you take the source code, it goes through the interpreter, and you produce an output. Only 3 steps. Whereas the compiler process, you take the source code, it goes through the compiler, then it turns into machine code, and then you get the output, which is 4 steps. So therefore, the interpreter is slightly quicker when it comes to running the program, but in terms of performance, the interpreter is slower. Comparison to Python. To visualize the difference between dynamically and statically typed languages, let's look at an example between Python and Viper. In the Python code, change state function takes in one parameter. As a developer, we don't know the type of the parameter value, so this is prone to runtime errors if the developer passes in the wrong type. Meanwhile, change state in the Viper code is easier to understand because we know that the parameter should be of type integer. This gives more confidence in what the developer is passing into the parameter. As for the second function, Python does allow type hinting for the return value, but it doesn't enforce it. So in Viper, if the function does have a return value, then the return type must be enforced. In the Python example, I can pass in 2 integers and get an integer, but also I can pass in 2 strings and get a concatenated string result. So I can pass in different types and possibly get different results, which is problematic because it can bring unpredictable results to the value. Statically typed languages. So the benefit of using statically typed language is it prevents many runtime errors from occurring, like an example that we showed in the previous slide. We didn't know that the parameter type in the Python code, but because we did in Viper, we can confidently pass in the correct type and not get an error if you passed in the wrong type. And this is more of a personal opinion, but as better code readability. When you're reading code, you want to make sure that you understand what's actually going on, right? With variables, I want to make sure I know what the type of the variable is, because if I don't know what it is, then I might read the code wrong, and that would be unfortunate. And it's actually easier to maintain a project when you have types, because people are constantly reading code more often than they write. So they have to make sure they understand the code base before they can actually start writing code and getting the output that they want. The two components of a language are the lexer, or also known as the tokenizer, and the parser. The lexer converts a sequence of characters into tokens. So as you can see here, 2 plus 4, it goes through the lexer, and then it produces a token for each character. So 2 is assigned to num, plus is assigned to plus, and 4 is assigned to num. And then after that, you have the parser, which breaks down the sequence of tokens into programmable logic. This means that the parser will take these tokens, num plus num, and make an abstract syntax tree based on those tokens. So you have the expression, and you break it down into a tree. 2 plus 4. And then in the end, this will result as 6 as the value, because we know that this is a mathematical expression here. So by next semester, for next semester, my goal is to work on transpilation, a process where the code is converted into another code of a different language with the same level of abstraction. This basically means that, for example, TypeScript and JavaScript are both high-level languages. And TypeScript can convert its code into JavaScript. If you have a high-level language and you convert it into a low-level language, that's different. That's not transpilation. That's a compilation. Because you're converting a high-level language into a lower-level language. And then, as you can see here, we have Viper code, and then we throw it into the Viper transpiler, and then the output will be a Python code. So, features from Viper, like types, will not appear in Python. And then for the prototype, I can't make this full screen, but basically what I'm doing here, I'm creating a function called math, and it will return a value, an integer value, and then I'm creating a variable called x, and then I'm printing it out based on the math function. And then I'm creating another variable called y, which will print the value of y. As for the timeline, so far, I've only worked on creating integer float and boolean variables. I've also done built-in functions, like the print statement. And also custom functions, like creating your own function. And also conditionals, like if this is true, then do this block. In December, I plan to continue on starting for and while loops and array initialization. January and February, classes and object creation, then parse constraint characters and objects. And then also in January, I want to focus on starting the transpilation process. I feel like next semester, the transpilation process is going to be my main focus here. And then March and April, I'm going to continue more on the transpilation and then do the cleanup code. Because right now, some code are kind of messy. So I want to make sure I clean things up, make sure it's readable and there's some documentation. Overall, that's all I have for my progress on the thesis. Right now, it's mostly just setting up the parser to parse expressions and get an output from it. And then next semester, my goal is to focus more on transpilation, converting Viper code into Python code. Thank you.